Today I would like to summarize again Raoult's law, interaction of particles in liquid solutions, and vapor pressure versus escaping tendency, and also the ideal and non-ideal solutions, delta H mixing and delta V mixing, positive and negative deviation. Oh, even though we have discussed all these earlier, but a quick revision is necessary. जल्दी से हम इसको दोहरा दें और तब आगे हम उसको फिर से पढ़ेंगे. Raoult's law states that the partial vapor pressure of each volatile component in a solution is directly proportional to its mole fraction. और ये मोल फ्रैक्शन और पार्शियल प्रेशर के बारे में हम अच्छी तरह से पहले समझ चुके हैं. और उसके बाद हमने ये भी पढ़ा हुआ है that interaction of particles in a liquids and solution. In a liquid means pure liquid which has only one type of particle, there is an interaction between the particles. Particles are never static. They are always in a state of constant rapid motion in all possible directions with the help that there is an interaction of the particles, maybe repulsive forces and attractive forces in between the particles of a liquid. Now, these particles may be molecules, of course. And then, when we mix the two solutions, what happens? Both the solutions, suppose we call it there is a solution A and there is a solution B. Now, solution A, or what we say as liquid A, we won't say it's solution till they are mixed together. Now, liquid A in the pure state has AA interaction. Particles of A interact with particles of the liquid A. And similarly, there is a pure liquid which is identified by liquid B, then their particles interact together similar to AA as BB interactions. Now, when we mix the two solutions, what will happen? When we mix the two liquids, what will happen? A binary solution will be formed. Binary solution means a solution containing two liquids, miscible liquids, which can intermix with each other. Now, here what happens that because of their homogeneous correction nature and their intermixing, what happens that a new interaction between the particles of liquid A and liquid B comes into play, and that interaction is known as AB interactions. So what we know that in a solution there are three types of interactions between the particles. Particles of AA interaction, BB interaction, and AB interactions. Now these interactions may be similar or may be different to a certain extent, may be widely different even then. So what happens that the liquid contains three different particles, and if the interactions of AA, BB and AB interactions are similar, we call it as a ideal solution. Ideal solution means it will obey Raoult's law to greater extent. Actually, no solution is an ideal solution. It may be close to ideal. And therefore, even then we say that they are ideal solutions. Ideal solutions mean which follow Raoult's law under all conditions of concentrations and at a particular temperature. Now, in an ideal solution, delta H mixing is equal to 0, and also delta V mixing is also equal to 0. All this we have learned about. Means there is no heat change, there is no enthalpy change when they are mixed together. Similarly, when they are mixed together, there is no change in volume. All this we have discussed earlier, and we know that if 100 milliliter of a liquid is mixed with 100 milliliter of another liquid, the total volume will be 200 milliliter, provided they behave ideally. there will be no heat change, there will be no enthalpy change, and that will be an ideal solution. So, this is all what we have discussed earlier.